Hey everybody, this is Unit 5. We're going to learn about congruent figures. Our essential question is, how can you identify congruent triangles? So congruent figures have to be the same size and the same shape. And two figures that are the same size and the same shape are called congruent. So these triangles down here are congruent. So saying same size and same shape is a general way, like a mathy way to say it is that they have all the angles are the same, they have matching angles, and they have matching side lengths. So corresponding angles are congruent. The angles that match, we call those corresponding angles. So angle B and angle E are considered corresponding angles. They have the matching angle. So whatever this angle is, how many degrees that is, that's how many degrees this one will be. And the length of side AAC here is going to have to be the same as the length of side DF. All right, so let's look at example 1. They tell us that the figures that they show us are congruent, so that means they have all equal corresponding angles and corresponding sides are the same. So what we need to do is figure out which angle and which side corresponds from one to the other. So corresponding angles. Angle A is this angle right here. And in the other figure, angle W looks like it's in that same position, same size. So angle A and angle W are corresponding angles. Angle B looks like it corresponds to angle X. So angle B and angle X are corresponding angles. Angle C corresponds to angle Y. So angle C and angle Y are corresponding angles, and then angle D and angle Z are corresponding angles. So that corresponding angles means that the angles are in the same position with respect to each shape, right? Angle A and angle W are in the same place, so they have the same measurement. So then the sides, side AB is congruent to side WX. So AB and WX are corresponding sides. Side BC over here is going to correspond to side XY. Side CD is going to correspond to side YZ. And side AD is going to correspond to side WZ. And so these little notations that I've made here, the little arc in the angle, that shows that angle A and angle W are the same measurement. When I do two arcs over here for angle B and angle X, it shows that they are congruent, so they have the same measure. For showing that sides are congruent, you can do a little hash mark through the side. This hash mark, these hash marks show that side AB and side WX are congruent. And then to show like a different size side that's congruent, you just do two hash marks to show that those are congruent. You could do 3 hash marks to show that these are congruent, and so forth. Okay, so these figures are congruent, and we're going to name the corresponding angles and the corresponding sides. Angle K corresponds to angle R. So angle K and angle R are corresponding angles. Angle L corresponds to angle Q. And so you'll see like these two images, they're not oriented the same way. Angle L and angle Q are the same measure angle, but they're not like pointing in the same direction. You can kind of see that angle J is this narrow acute angle, and the only one that matches on the other one is angle S. So these ones are kind of pointed away from each other. But that shows us right there, angle J corresponds to angle S. But let's go in order. K, L, M. Angle M corresponds to angle V. Angle N corresponds to angle T. And angle J corresponds to angle S. Now the side lengths. So side KL corresponds to side RQ. And you have to start at the same, you notice how angle K corresponds to angle R? So if we start and say K to L, we'd have to go from R to Q. So this is KL, you're going from K to L. That corresponds to RQ because that's like going from R to Q. So side KL and side RQ correspond. LM corresponds to QV. MN corresponds to VT. NJ corresponds to TS. And then JK corresponds to SR. Now one thing that you should notice is that if we label this, we call this top one, call that KLMNJ. And that is congruent to, and we have to use the corresponding letters. So KLM, we would go RQV, RQVTS. And then one thing you can notice is that corresponding angles, K and R, would be in the corresponding positions in how we name the polygon there. So M corresponds to V, M and V are both in the very middle position when we name this. So the positions when we name the polynomial or the polygons, the corresponding letters are in the corresponding positions of the names. Here's a big idea. Two figures are congruent when the corresponding angles and the corresponding sides are congruent. So if you see shapes or figures that have corresponding sides congruent and corresponding angles congruent, then you can say that the whole shape is congruent to the other one. So since angle A is congruent to angle D, angle B is congruent to angle E, angle C is congruent to angle F, and then side AB is congruent to side DE, and so forth. That's the little hash marks show that the sides are congruent, and the little arcs show that the angles are congruent. If all the sides and all the angles are congruent, then you can say that the triangles are congruent. Okay, example 2. Which square is congruent to square A? Well, they're all squares, so that means that they all have right angles. So they all have right angles, so the corresponding angles are congruent. So all the angles are right angles because they're all squares. So all of the angles are congruent, but we need to see if corresponding sides are congruent. If you look at squares A and B, they have different side lengths. So that means that the corresponding sides are not congruent. So square A and square B are not congruent. If you look at squares A and C, all the side lengths are 8. So the corresponding sides are congruent because they have the same length. So since all the angles and sides for squares A and C are congruent, then we can say that square A is congruent to square C. All right, example 3. They tell us that trapezoids A, B, C, D, and J, K, L, M are congruent. And they want to know, what is the length of side JM? Well, side JM starts at J and goes to M. Draw that. So JM is here. It starts at J, goes over to M. That corresponds to AD. And you can see that JM and AD are in corresponding positions in the name. So JM corresponds to AD. Well, if they correspond and the two shapes are congruent, that means that the side lengths are congruent. So that means that if AD is 10 feet, then JM is also 10 feet. All right, in B they ask, what is the perimeter of JKLM? Well, since these are congruent, they would have the same perimeter because they're going to have all the same side lengths. So we find the perimeter of ABCD, which is just adding up all the side lengths. 10 plus 8 plus 6 plus 8 is 32 feet. And because the two trapezoids are congruent, the corresponding sides are congruent, so that means they're going to have the same perimeter. And that perimeter is 32 feet. Okay, so for practice, number 2, which square in example 2 is congruent to square D? Well, here are the squares from example 2. And remember, squares all have the right angles, so the angles are all congruent. And it looks like, based on congruent side lengths, that square B is congruent to square D because all the angles and all the sides are congruent. In example 3, which angle of JKLM corresponds to angle C? Well, angle C is in the same position, and if we think about this, A, B, C, D, C is in the same position as L, and if you look at the picture, L is in the same position, so angle C corresponds to angle L. There's another question, what is the length of side KJ? KJ corresponds to BA, and BA, we look over here, is 8 feet. Since they correspond, they have the same length, so JK equals 8 feet. All right, folks, that's the end of the lesson video. Hope your notes are rad. Check you later.